Okay, so DSMA 8 is factoring binomials. So again, if you want some more practice, just like with the factoring trinomials, you can go to khanacademy.org and just type in factoring binomials, and they're going to give you problems to try. Now, we're not going to do any of the difference or sum of cubes in this class. If you go on in math, you'll get to do those later. We're going to just mess with difference of squares. So these are the easiest to factor. But they're not always going to say to you, factor the difference of two squares. If they said that, that'd be great. But they're probably just going to say factor. So what we want to do is we want to look for when we have two terms, and then we want to see if the first term and the last term are perfect squares. Now, we do still have to check for greatest common factor first. That's always important because sometimes it doesn't look like they're two perfect squares, but as soon as you pull out the greatest common factor, you'll see that they are both perfect squares. So in this case, when we go to try to pull out a greatest common factor, nothing. We have a 1 in front of the x squared and a 9. We don't have any extra x's. So what we're going to do is let's think about these being perfect squares. So the x, we have x squared. So if we put an x here and an x here, if we multiply those two back together, we get x squared. And then 9 is a perfect square, right? 9 is 3 times 3. And so if we put the 3's on the other end, when we FOIL, we would get 3 times 3, which give us 9. However, we need a negative 9, right? And so what we're going to do is we're going to put x plus 3 and x minus 3. So this is how difference of squares work. We actually, and I think I have a slide in a little bit, we cannot factor a sum of squares, and I'll show you why when we get to that slide. But this is how difference of squares is going to look. So let's come over here and check our work. So this actually is the answer, but let's go ahead and FOIL. So if we FOIL, our first two terms, x times x, would give us x squared. The outer term would be x times negative 3. The inner term would be positive 3 times x. And finally, the last term would be 3 times negative 3. All right, so notice these middle two terms would give us 0, right? Negative 3x plus 3x. And so we're just left with x squared minus 9. And so our check works. Okay, so it is important that we have both a plus and a minus. Otherwise, we're not going to get the negative number at the end. All right, again, this problem was very nice and said factor the difference of two squares. But we would know, even if it just said factor, because it's two terms, that's one of the first things we're going to check for is see if it's a difference of squares. Next, we're going to look for the GCF. Well, there's no numbers in common, there's no variables in common, so there's nothing we can do with the greatest common factor. So now we're going to look at whether these are both perfect squares. Well, in front we have 4, so 4 is 2 times 2. Then we have x squared, so that would be x times x, right? So those are perfect squares. On the other end, we have 25. Well, 25 is 5 times 5. So we would have a 5 on each end. And then because we want those two middle terms to equal 0, and because we need to multiply the two 5's and get negative 25, we want to have a plus and a minus. Again, the order does not matter. You can put the negative first, or the subtraction, excuse me, first, and then the addition does not matter. It would still be correct. All right, so we're going to check our work, but this is actually the answer. Okay, so let's come over here and check. We're going to FOIL. All right, so 2x times 2x gives me 4x squared. 2x times negative 5 is negative 10x. Positive 5 times 2x is positive 10x. and then 5 minus 5 gives me negative 25. All right, so these middle terms give me 0. Negative 10x plus 10x is 0. And so I get back to my 4x squared minus 25. All right, so here's one of our problem children. At this point, we do not have any tools to factor this. We cannot factor a sum of squares. So this is a sum of squares because we have x squared and we have 144 is 12 times 12. We cannot factor this. All right, so let me show you why. Let's come over here. If I tried to put the x and the x and the 12 and the 12, all right, well, I can't do a plus or a minus because we need to have a positive 144. All right, so if we put the positive in here, now when we go to check our work, when we FOIL, you'll notice that we get a middle term and we do not get back to the original problem. Right, this does not match because I end up with this middle term. Okay, so we cannot factor a sum of squares. If you see the plus sign, we cannot factor it, and we're going to say that this polynomial is prime. We can factor a difference of squares. If that had been subtraction, then we could have done this problem. All right, so this problem looks crazy also. It is subtraction, so that's a good thing, but I don't really know right now if I can pull a greatest common factor out or if these are perfect squares or what. So since they're such big numbers, the first thing I'm going to do is just check. I'm going to go to my calculator and I'm going to go ahead and check if these are perfect squares. So if I put the square root of 169 in my calculator, sure enough, I get 13. That one I did know just because I like the number 13. Okay, then I'm going to check 196. So if I take the square root of 96, I also see that I have a perfect square. If I get a decimal, then these are not perfect squares. At that point, I would want to check and see if I have a greatest common factor that I can pull out. But since neither one of these has decimals, because I get an integer of 13 and 14, I know that these are both perfect squares. So now what I have to do is very carefully, because I have a lot going on in here, I'm going to take the 169, and that would be 13 times 13. Then I'm going to put the x in there, right, because it would be x times x would give me x squared. Then I'm going to come on the other side. 196 is 14 squared, so I have 14 times 14, but don't forget the y right here. So I would need a y here and a y here. All right, so I'm almost done. I took the first term and I took the square root of 169, that was 13, put that in both the binomials, and then the x in each of the binomials. Then I took the square root of 196, that gave me 14. So I put 14 in each of the binomials and the y. So y times y would give me back to the y squared. And then don't forget you need a plus and a minus. So this one is crazy looking, but it's still just those rules for difference of two squares, where you're going to break up the perfect squares and then have one be addition and one be subtraction. So this one's a little tricky, and it's actually a two-step problem. So you can be pretty sure this one's going to show up a few places, like a quiz or a test. So the first thing we'll do is look for a greatest common factor. There's none because the first term just has a 1, and the second term doesn't have any x's. All right, now we haven't really talked about this, but x to the 4th power is actually a perfect square. Any even exponent is, because this is x squared times x squared. Trying to get a little dot there so that it looks like multiplication, but my stylus doesn't want to let me. Okay, so if I go to separate this into two binomials, the x to the fourth I can split up into x squared and x squared. All right, then I want to take that 256, check it in my calculator. Let's see what we get. 16. Okay, so I can put a 16 here, a 16 here. I have a plus and a minus. Okay, so, and if I checked my work, I would get back to that original because x squared times x squared gives me x to the fourth. The middle terms would give me 0 because I would have negative 16x squared plus 16x squared. And then finally at the end, I would have the negative 256. However, put this into your computer, into my math lab, it would tell you that although you have the correct answer, it is not in the correct format. And that is because this second one can be factored one more time. It's also a difference of squares. The first one cannot. This is a sum of squares. We cannot factor that one again. And so that one would have to stay put as x squared plus 16. However, we can factor the x squared minus 16. So we have x and x. We have plus 4 and minus 4 because 16 is 4 times 4. Now we're factored as far as we can factor. Okay, and this is really important when we get to where we're looking at graphs and factoring and trying to see where a function crosses the x-axis. We use factoring to do that, and it's very important. But we have to make sure that we factor completely. All right, one last one. 18y to the fourth minus 50y squared. All right, so we have lots of y's in there. We know we can get rid of some y's. If you check in your calculator, or if you just know your perfect squares, 18 is not a perfect square, and neither is 50. You would get a decimal. If you took the square root of 18, you would get 4.2426. It would go on and on. Same thing, square root of 50. These are what we call irrational numbers. So let's go ahead and take care of our greatest common factor. We're supposed to do that all the time first anyway. All right, so if we look at 18 and 50, we definitely have a 2 in common. I think that's it. All right, so we have a 2 that we can pull out to the front because that's in common to both 18 and 50. Now with the y's, we're going to take the smallest exponent, right? We can't take 4y's away from 2y's, but we can take 2y's away from 4y's. So we're going to go ahead and pull the y squared out of there. Okay. So let's go ahead and do our dividing here because this is, when things start to look a little crazy, I go ahead and just write the whole thing. All right, so we're dividing 2y squared from both of these. You do not have to do this middle step. That's up to you. All right. So 18 divided by 2 is 9. Y to the fourth over y squared gives me y squared. On the next one, I have 50 divided by 2, which gives me 25. And y squared over y squared is 1. Okay, and I, of course, could check my work by bringing the 2y squared in, multiplying in, and check my work. Okay, so now this looks a little better because now I have 9, which is a perfect square. I have y squared, which is a perfect square, and I have 25, which is a perfect square. But do not forget your greatest common factor out front. That has to stay out front. All right, so we've got 9 would be 3 and 3. Y squared would give me y here and y here. 25 on the other end is 5 times 5. And then finally, I need a plus and a minus. Okay, so that greatest common factor is really important because sometimes you're going to be really quick to hit that polynomial's prime, and it is rare that we give you a prime. There was one so far between the two sections. So try and see if you can pull a greatest common factor out and then look at what's left inside the parentheses. Most likely what's left inside the parentheses can factor further. If it can't, it's still not prime if you pulled a greatest common factor out.